Bulletproof glass. Now let's talk about bulletproof glass. Glass itself is very brittle. In fact, cracks move through the glass faster than bullet trails. Researchers from high-speed ballistics have demonstrated this in high-speed tests. I will show you the footage.
Plate glass. That's some fierce travel. It got basically all of its main cracking done before the bullet became flush. That's nuts. That is so fast.
So, how do you stop a bullet? Just stacking lots of glass layers doesn't really work.
Whoa, that's cool.
It would be too thick and unbelievably heavy. Using regular laminated interlayers like hurricane glass, too thin. The real solution is combining regular, non-tempered glass with layers of polycarbonate.
Bulletproof is normal glass versus Silatech glass.
Feel free to come here, take a look. You can see all 3 sheets of glass if you look in there at an angle. Of course, that was to be expected. I just wanted to show it to you. You can see that it really is splinter-free.
Not a single splinter.
There's a challenge though. Glass and polycarbonate expand at different rates when temperature changes. Bonding them properly is not simple. I had the opportunity to work with Silatech company from Germany, one of the leaders in this field. They developed a special transparent bonding material that fills the space between glass and polycarbonate. And even now, it kind of like very flexible. So it stays flexible for a long time when it cures. Similar, I think it's similar to polyurethane. By alternating layers of glass and polycarbonate and increasing the number of layers, manufacturers create different levels of ballistic protection. From small caliber firearms all the way up to protection against sniper rifles or even Kalashnikov. About 15 years ago, we had a fascinating project, making the entire facade of a 5-story building owned by a VIP client in one of the European capital North European country, fully bullet resistance at BR6 level. Silatech had BR6 glass available, which is 42 millimeters thick, and it weighs about 90 kilos per square meter, or roughly 20 pounds per square foot. The problem, the facade system used in that building could only handle glass units up to 36 millimeters thick. A full BR6 insulated unit would have been 70, 80 millimeters thick. We considered mounting BR6 panels behind the facade structure, but that would have blocked windows and doors and created a massive dust trap over time. So I came up with another solution. We used Vitrox TH Plus system and designed sliding protective panels that allowed access to windows and doors and made it possible to clean between the facade and a bulletproof layer. The panels were sized so that their overlap lined up perfectly with behind structural mullions. Ensuring protection from any angle of fire. 15 years later, our client is still doing well, and we have never received a complaint, and I believe the structure works well.